Hello all, in this particular video we will see how to remove duplicate elements in a single linked list. For this purpose we are adding some elements by using insert at beginning function. So I'm adding 4 3 1 2 1 2 1. So as you can see here there are some duplicate elements are there, and we are printing the original list, and after printing the original list I am calling remove duplicates function. So this function is a user defined function. It will remove all the duplicate elements from the single linked list. Once the duplicate elements got removed and we are displaying the updated list, by using print list function we are displaying the updated list. Let us see the sample input and sample output. So this is the original list. As you can see here we are having duplicate elements in this list, and after removing duplicate elements, this is the updated linked list that is free from all the duplicate elements. Now let us see the implementation of remove duplicates function. I'm going to the definition. So remove duplicates function, we are having three pointers here. One is current, another one is prev, and another one is temp. So initially current is pointing to the head, and we are traversing the linked list by using a nested loop. So outer loop is basically to traverse the list, and inner loop is basically to check if there are duplicate elements or not. If there is no duplicate elements, then we have to move forward in the linked list. That is the logic here. Instead of going to each and every line of the code, I will take one example, and I will explain how this function works with that example. Now let's get started. So this is the algorithm. As you can see here, as I already discussed, initially we need to set current to point to the head of the linked list. So current will point to the first node itself, and head obviously point to the first node only, and outer loop to traverse the list. So basically at the outer loop, whatever the outer loop is they have mentioned, that is to traverse the list, while current is not null. So current is basically moving in the outer loop. Okay, while current is not null, we have to initialize two pointers here. Let us see that. While current is not equal to null, prev will point to the current only. So that means prev will point to the first node itself, and temp, we will take one more pointer called temp that will point to the current next. So what does it mean? So prev points to the first node, and temp points to the second node. I will show you the diagram. So this is the example which we have taken, and see this head is pointing to the first node, and current and prev both are pointing to the first node, and temp is pointing to the second node. Now we have to compare the current data with temp data. Okay, for this purpose inner loop will be there. So while temp not equal to null, if temp data, what is the temp data is 2, is 2 double equal to 1, the condition false, we are skipping this if what. Basically if there is a duplicate element, we have to delete that duplicate element by using a free function. This logic is present in if block, but in this case we are checking 1 and 2 nodes, right? We don't have any duplicate elements. 1 and 2 are distinct elements. Okay, so if condition will be skipped and else part will get executed. Now we have to move temp to the next node and previous to the next node, so such that adjacent elements will be compared. So temp will move to the third node and prev will move to the second node. So let's see. Now this is the updated linked list. Prev is at second location and the temp is at third location. Now again inner loop starts. We have to check if there is any duplicate element or not with current data. Current data is 1 and temp data is 1. So there is a duplicate element. So this temp should be removed. So how to remove this temp? We have to somehow uh, grab this address and put it in the priv next part. That is the logic, so that we don't have a link here. So we will miss this link somehow. So we have to delete this temp, right? What I'm highlighting, we have to delete this temp. How to do this? Take the temp next value. What is the temp next value? 300. Take that, and inside priv next there is a 200. No, 200 is there, right? In this 200, assign 300, so that the link will be missed, and then we can freely delete the temp. Okay. So what is the temp next value? Temp next value 300, and initialized in priv next part. So let us see the updated diagram. So this is the updated diagram. So that link got deleted, and we are having this link. So now this 2 and 4th nodes are interconnected now. Now we can delete this free temp. So temp will got deleted, and there is another line. So temp is equal to priv next. What is priv next value? Priv next value. What is priv next value? Priv next value 300. 300. Okay. This is okay. Temp should be moved. So what is the priv next value? Priv next value is 300. Initially temp is at the third node, right? We have to move the temp value now. After deleting the temp value, we have to move the pointer to the next node. How to do that? Priv next value is what is priv next value? So this is the priv next value is 300. 300 should be assigned in temp, so that temp will move to the 300th location. So this is what the updated linked list as follows. Current is pointing to the first node, priv is pointing to the second node, and temp is pointing to the third node. Okay, again inner loop starts. We have to check whether temp data and current data is equal. If temp not equal to null, while temp not equal to null, temp data and current data both are not equal, because current data is 1 and temp data is 2, both are not equal. This condition will be skipped. Now we have to move the temp part and priv part, priv to the next node and temp to the next node. So initially priv at 100th location, now priv will move to the 300th location, and temp will move to the 400th location. So this is what the updated linked list diagram as follows. Now check whether temp data and current data, again inner loop starts. Temp data and current data is equal. Yes, it is equal. Now we have to somehow delete this temp. After deleting the temp should move to 500 location. How to do that? Now let us see. What is the temp next value? Temp next value is 500. That 500 should be replaced in priv next. So temp next value, take that temp next value. Temp next value is 500, and after that initialized in priv next. So the updated diagram looks as follows. So in here 400 is there, now it is 500. So that link is formed, and we can directly delete this free with free. We have directly delete this temp with free function. Now temp should move to the 500. How this is possible? Priv next. What is priv next? Priv next is 500. So 500 will be assigned in temp, so that temp will move to the 5th location. So this is what the updated diagram looks like. And yeah, now we need to check again inner loop starts, but as you can see here, we don't have any duplicate elements. Okay. Okay, we have so I'm sorry for that. We have a duplicate element. This will removed in the second further iterations. Let us get started. So now again inner loop starts. While temp not equal to null, again temp data will be compared with the current data. But unfortunately we don't have any duplicate elements, so we have to move this temp to the next part and priv to the next part. So priv will point to the 500, temp is point to the 600. And again we don't have any. I am skipping forward because this is a unnecessary step. So now we don't have a duplicate elements, right? Temp data is not equal to current data. So now temp will move to the next location, prev will not move to the next location. Unfortunately, temp next location is null, so temp will becomes null here. Okay, so temp is null and prev is at lost position. So again inner loop starts, but while temp not equal to null, so null not equal to null false, we are breaking from the inner loop. Now this current will move to the second node. This current is at the first node, right? This current will move to the second node. How this will happen? Because after inner loop I will show you the code. After inner loop we are having this statement, current is equal to current next. Initially the current is at first location. Now current will move to the second node. So that is what happens here. So head is at one location and current is at second location. Now we don't have any prev and next, so this will get updated now. Now we are in the outer loop once again. Is current not equal to null? Current should be traverse, right? So is current not equal to null? Condition true. Now again prev and current, now again prev and temp will reinitialized. Prev will be initialized at the second node. I mean to say prev will point to the second node and temp is pointing to the third node, because temp is equal to current next. So this is the updated diagram. So current and prev pointing to the second node only, and temp is at third node. Third node, yeah, the 300th location. Now we are in the inner loop and we have to check temp data and current data whether they are equal or not. Temp data is 2 and current data is 2, and there is a duplicate element. We have to delete this temp. How to delete this temp? Take the temp next value. What is the temp next value? 500. This 500 is to replaced in prev next part, so that this link will be missed. And after removing this temp, and what is the prev next part? Prev next part will be the 500, right? Prev next part will be the 500, so that temp will move to the fourth location. So this is what the updated diagrams looks like. So prev next part is 500. Initially temp is at this temp whatever the deleted node, and temp will be moved to the fourth location. Now you can free this. After freeing this only this will happen. So the temp will move to the fourth node. That becomes the third node, because after removing this, fourth node becomes third node. That is the meaning here. So now current is at second location, temp is at third location, and again inner loop starts while temp not equal to null. Temp is at 500. 500 is not equal to null. We are inside the this loop. Duplicate loop. Inner loop is to say to check the duplicates, right? That's why I'm saying duplicates loop. Forgive me for that. Yeah. So now what is the temp data? Temp data is 3 that needs to compare with current data, but we don't have a duplicate elements. So temp will move to the next node and prev is move to the next node. Prev will point to 500 now and temp is point to the 600 now. So prev is point to the 500 and temp is point to the 600. Again inner loop starts while temp not equal to null. Yes, temp is not equal to null, and we don't have a duplicate elements, but this traversing will happen anyhow. Yes, so temp 600 not equal to null, temp data 4, and compare with the current data. We don't have a duplicate elements. Now temp will move to the next location and prev will move to the next location. Unfortunately, temp next location is null, and temp will be assigned in null, and prev is pointing to the last node. Again inner loop check will be happen while temp not equal to null. Since temp is null, null not equal to null, condition false. Again current is at second location, right? Now current will be moved to the third location. That's what happens. So this is the updated diagram. Current is at third location and temp is at uh, okay, now temp got deleted and current is moved to the third location. So what is the initial? Now we are in the outer loop. Priv should be point to the current node. So priv and current both are pointing to the third node, and temp will be moved to the fourth node, because temp is equal to current next. Current next value is 600. So temp should be pointed to the 600th location. Now we have to check whether the outer inner loop is, we have any duplicate elements or not. How do we check? Again, inner loop, is temp not equal to null? Anyhow, I am skipping this part. 4 double equal to 3, is 4 double equal to 3? No. And we have to move the pointers. Temp will move to the next location, so temp will becomes null, and current is moved to the fourth location. So this is what the updated diagrams look like. Yes, current is at fourth location and temp will becomes null. Now while current not equal to 0, 600 not equal to 0, again prev will point to the 600 and temp will becomes null only. Temp will becomes null only. While temp not equal to 0, inner loop begins, but unfortunately temp is null now. Null not equal to null, but the condition is false. After inner loop, we have a statement called current is equal to current next. Now current becomes null. The total traversing is done. We have nothing left because the current is null only here. We are at the end of the linked list. So current not equal to null. So null not equal to null condition false. We are breaking this loop again. We are breaking from the outer loop. So this is the updated linked list that is free from all the duplicate elements. So the time complexity is order of n square because of the inner loop traversal. So this is the quadratic time in the worst case. So this is how the removal of duplicate elements happened in the single linked list. So this is what this is the logic, and this is the sample input and sample output. That's it for this video. Thank you so much.